Hello everyone, welcome to my channel. I'm Ogbu Omenka. Today I'll be solving a question. The question said, given that E, which is a Hamiltonian operator for a wave function, is equal to what? E, which is the total energy of the system. Determine the E for the system using the appropriate H, the Hamiltonian operator, in the relations to the wave functions. Wave function is equal to 2 over L, all in bracket, 1 over raised to the power 1 over 2. That is square root of 2 all over L sine n pi x all over L for a particle in one-dimensional box where the potential energy V is 0 for 0 less than x, x less than L, and infinity for x greater than or equal to L, x less than or equal to what? 0. Please, before we continue on the solution to the question, I would like you to click on the subscribe button. Thank you. Here is an answer to the problem. Recall that from time-independent Schrodinger equations, the H wave function, which is a Hamiltonian operator, is equal to minus h cos squared 2m d squared wave function all over dx squared plus v wave functions. Since from the question we are taught that the potential energy of the system is equal to 0, therefore V is equal to 0. And if V is equal to 0, then the Hamiltonian operator, which is a H wave function, is equal to minus h cos squared all over 2m times d squared wave function all over dx squared. Given that from the question, wave function is equal to 2 all over L raised to the power 1 over 2. That is the square root of 2 all over L sine n pi x all over L. Substituting it into the Hamiltonian operator, h wave function is equal to minus h cos squared all over 2m times d squared all over dx squared bracket 2 all over L raised to the power 1 over 2 sine n pi x all over L is equal to, having the first derivative, we have it to be minus h cos squared all over 2m d all over dx bracket d all over dx 2 all over L raised to the power 1 over 2 sine n pi x all over what? L. Here we're going to differentiate 2 all over L raised to the power 1 over 2 sine n pi x all over L. If you're having difficulties in doing that, how to differentiate that, there's a video concerning that. The link is below this video. Please click on the video. Click on the link to access the video on how to differentiate sine n pi x all over L. Thank you. Let's continue. So is equal to, differentiating the above, we have it to be equal to minus h cos squared all over 2m times d all over dx bracket. If you are differentiating with respect to x, d all over 2 all over L raised to the power 1 over 2 is a constant. You keep it constant, then you differentiate sine n pi x all over L. Then you keep sine n pi x all over L constant and differentiate 2 all over L raised to the power 1 over 2. And since 2 all over L raised to the power 1 over 2 does not have any x term in it, so differentiating with respect to x, it becomes a constant and is equal to 0. Therefore, the whole of that one is cancelled out. Then we differentiate 2 all over L raised to the power 1 over 2 d all over x sine n pi x all over what? L. When you are differentiating sine, you have it to be what? Cos. That is because it's a trigonometry what? Function. And this is a constant term. Differentiating sine, you have it to be what? Cos. And you also have n pi x all over L inside the sine function. Therefore, we're going to use what? A chain rule, because sine n pi x all over L is a composite function. That is what I say, click on the link below in order to access the video on how to differentiate sine n pi x all over L. let's continue. So differentiating 2 all over L raised to the power 1 over 2 n pi all over L cos n pi x all over L. What will have it to be? You keep 2 all over L all over 1 raised to the power 1 over 2 constant and differentiate cos n pi x all over L. And in doing so, you keep it, then you keep cos n pi x all over L constant and differentiate 2 all over L raised to the power 1 over 2. And since 2 all over L raised to the power 1 over 2 doesn't have any x term, it becomes a constant. So differentiating with respect to x is equal to what? 0. If the whole of that one would cancelled out. Then we are left with minus h cos squared all over 2m bracket 2 all over L raised to the power 1 over 2 n pi all over L times n pi all over L bracket minus sine n pi x all over L. Then minus times minus is equal to plus. Then n times n is n squared, pi times pi is pi squared, L times L is L squared. Therefore, have it to be h cos squared all over 2m n squared pi squared all over L squared bracket 2 all over L raised to the power 1 over 2 bracket sine n pi x all over L. Since from the question wave function is equal to 2 all over L raised to the power 1 over 2 sine n pi x all over L, therefore the Hamiltonian operator, which is h wave function, is equal to h squared, h cos squared all over 2m times n squared pi squared all over L squared, then all multiplied by what? The wave function. Rearranging this have it to be the Hamiltonian operator h wave function is equal to n squared pi squared h cos squared times the wave function all over 2m L raised to the power of 2. Comparing with the expression h wave function times e wave function, we have it to be n squared pi squared h cos squared times the wave function all over 2m L squared is equals to e wave function. When the wave function cancels the wave function, we will have it to be, therefore the en is equal to n squared pi squared h cos squared all over 2m L squared. From the expression, we can say that the total energy of the system is quantized, since we have an n term that stands for the quantum number. Recall that since h cos squared is equal to h all over 2 pi, you can also have the expression to be en is equal to n squared h squared all over 8m L squared. Thank you for watching. Please click on the subscribe button to have access and to be notified to other videos when posted. Thank you.